In the many examples I've seen, using Weka or Meka typically use the UI, which is very nice and helpful in understanding the dataset and refining the model, but not so many examples using Java. The ones I've seen using Java typically work on the ARFF file format. I couldn't find as many using the Weka Meka Java classes. In this series of short videos, I'll show examples on using Meka in Java. First, let's take a quick look at the ARFF format. This is from a common example, identifying the flower type given other attributes. The first line, @relation, just gives the dataset name, followed by 4 attributes used to describe the flowers. The last attribute, the class, is the attribute noting the final type. This is the attribute to be predicted given the other values. Now the Meka format and the example structure I'll be using in my examples, identifying activities given various conditions. In this example I have 3 attributes, temperature, weather conditions, and level of activity, which may be used to determine or guess at 4 possible activities: watching football, going snow skiing, going to the park, or reading a book. Each of these values have a defined list of possible or nominal values. Weather conditions may be clear, snowing, or raining. Temperature may be hot, warm, or cold, and the level of activity may be either lazy or energetic. Each of these activities are simply yes or no. I'm building up the ARFF format by adding each line to a list of strings. The relation has the same name as the dataset, and the -d listing the number of target attributes. For Meka, these target attributes are at the beginning of the list of attributes. This is different than Weka, where the single target attribute is at the end. So in this case, I'm naming the dataset weather conditions and indicating that there are 4 target values. Then a line for each attribute, listing the name of the attribute, and in this case, the list of nominal values. Then I'm building a list of training values. I have a private convenience method to append the appropriate values in the ARFF format. Note that unknown values are indicated by a question mark. The question mark is a reserved character and doesn't have to be added to the list of nominal values. My training data consists of cases like, if the conditions are warm, clear, and you're feeling lazy, then the predicted activities may include watching a football game and reading a book. If it's cold, snowy, and you're feeling energetic, then you may want to watch a football game or go skiing. If hot, raining, and lazy, then watching a football game or reading a book may be appropriate. Once I have the list of strings, I need to convert it to the instances object. This can be done by first serializing the list into a single string, converting that string to an input string, and then converting the input stream into the instances object. Now I need to build a new ARFF dataset indicating the desired predictions. The header will be the same as the training data, same relation and list of attributes. Now for each attribute to be predicted, replace the value with a question mark. This will indicate where the trained model needs to fill in with the best guess. Running or evaluating the model will yield predicted outcomes. And this is just a quick example of using the ARFF format. Using the ARFF file format would be appropriate for static datasets. It works well. But when I'm trying to build the training model more dynamically, using a list of string values to represent the file format just doesn't feel right. I would like to use the Weka and Meka foundation classes to build the model. So in the next video, I'll show how to implement the same use case using the Weka and Meka Java classes directly.